So yeah, so this is it's exciting. This is Wardriving the Smart Grid, talking about a lot of different things about packet radios that relate to utilities. This is...
Yeah, I'm Nathan Kelter. I work with Shawn on our security assessments team, do penetration testing, stuff like that as our normal job. Occasionally we get fun engagements like one that sort of led to this talk. I also do some development for the Metasploit project. Shawn gives me a hard time because my hardware hacking skills prior to this project primarily included modding Xboxes and things along those lines.
Yep.
So.
Yeah, and I'm a principal consultant in Fishnet's security assessments team. Also, primarily we do network, web, physical, social engineering, pen testing, and stuff like that. I worked at a VCR repair shop in college, so that was my primary qualifications for electrical engineering and such. And I am in fact provably remarkably resistant to sustained 110 volt bursts. We've proved this numerous times. Now it does depend on the amperage, so preferably like sub 200 amp or so. But yeah, how sustained? A few seconds. A lot of the things that we were doing, we were working with live electric meters and other live devices and stuff, and these things a lot of them would have like a capacitor on the board that stepped it down to 5 volt, and I'm like, oh no, I can JTAG that. Yeah, it's just right there. That's all 5 volt, and there's like this big freaking capacitor right next to it. Oh, not right there. No, that's 110. Basically this is about talking about both sort of smart grid and dumb grid radio. Which is just sort of all this wireless technology that plugs all of the different types of utility systems together. Not just actually meters and a lot of people talk a lot about AMI, but this is about sort of all of the things that people are using for the wireless communication channels across the grid. And that also applies to gas, water, lots of other things.
Yeah, primarily there's lots of open standards. I mean, this stuff has been around for a long time. You can find documentation from, say, ANSI and some other people. They will sell you the various, similar to like RFCs for these SCADA protocols that'll tell you how all this stuff works. But there's a fair amount of vendor special sauce that kind of gets tacked on all around this and inside this. And so anytime you touch any one of these devices, you always have a mixture of interesting things that you can look and find anywhere, and then random proprietary stuff from these vendors, primarily in the RF space, which is what we're talking about today.
Yeah, and one of the things which is why we want to kind of point a lot of this stuff out, is that these guys are very much still in this model of culturally sort of thinking about InfoSec and all of that. It hasn't been as applicable to this particular industry. So they have a lot of the kind of things that you would see in 90s, like software security, data sheets and stuff, where they describe like proprietary encryption, patented proprietary encryption as an asset, or secret proprietary radio protocols and things like that. And that's actually used as a selling point, and you can go out to AMI vendors and utility vendor sites and see that as a security asset. And unfortunately, the people in utilities that are buying a lot of this stuff aren't aware that that's probably not a selling point.
So in all of this stuff, a lot of infrastructure that's been there for very long time, for decades, and with the advancement of wireless technology over the last 15 years, it's really become the fastest and easiest way to link up all these remote sites across, say, a city or a state. It's actually really expensive, to run lines out to every single device that may be, in a given area. And so what we've seen is that for a lot of actually good reasons, for overall cost and some of these types of things and ease of deployment, wireless is everywhere. So pretty much anything that you could hook up with a wire has been hooked up with wireless at some utility or another. Right?
Yeah, and a lot of this, specifically to where smart grid kind of comes into play is that, and we'll talk about that kind of further in as well, is that there's a lot of rapid push to get a lot of these things out. So there's a lot of things that traditionally might have been wired or might have just been something that required physical access to, that they now want to get plugged into everything else and tied in together. And so, the fastest path to do that is some kind of wireless tag. Yeah. And so just kind of defining some terms and things like that. You'll hear the term AMI a lot, advanced metering infrastructure. More commonly and actually more pervasive is going to be something called AMR, which is really just meter read type technology, automated meter read. So this is the kind of stuff that most of us probably have, out on our house. And so if you look at your meter and it says CellNet or something like that, a lot of those are just one-way reads. And so, like in the case of my utility, what they do is they just roll trucks around the neighborhood and via PagerNet stuff will go out and just pull read data from the meters. And so they're not walking around anymore. The next wave of that, obviously, and what you're seeing in the other different parts of the country is, and being adapted pretty rapidly, is more AMI. So then you're talking about two-way communication. You're talking about data coming from the home to the meter and upstream.
Yeah, AMR was what you saw utilities doing, say, 4 or 5 years ago, and that was sort of the natural progression where it was going, where it was the easy way to sort of start stepping into this more advanced world of digital reads and being able to lessen the number of people you had to actually send out to houses. With the push from, say, stimulus money, there was a lot of that was tagged on to smart grid infrastructure, and a lot of that has pushed in various regional markets around the U.S. Rapid adoption of advanced metering infrastructure, so like the full-scale stuff with all the bells and whistles rather than just the reads. So.
Yeah, and as far as the technologies that are in use, you're going to see a lot of proprietary RF, usually on the ISM, which institutional, scientific, and medical band, which is the same band that you'll see, a lot of other traffic that's kind of like this, but that's the 900 megahertz band.
Yeah, and we got into various discussions with RF engineers and some people that understood why a lot of these decisions were made. And we like to bash on proprietary protocols from time to time, but outside of the fact that it's closed and we don't really understand always how they work, there's actually were some really good reasons why they did what they did. The type of environment that they were in, envision, you've got to send very, very small amounts of information, right? It's like, a command to do this or that, or an acknowledgement, or maybe, here's how much electricity I've used, or whatever. So very, very small amounts of information that doesn't have to go very often, right? So really what you need is you just need low throughput, and you need it to be able to go a long ways and be able to get through like brick walls and, all these kinds of awful things. So as a result, most of these guys created their own sort of mesh networking stuff that's all proprietary RF that didn't exist out there as an open standard, so they went to this. Yeah. With a couple of exceptions.
Yeah, and a lot of this predates actually smart grid and all these other things. So these were companies that were around that were kind of a niche market for some of this kind of stuff before. So they had all this tech that integrated with other types of SCADA systems and all this other stuff. And now those companies are sort of already in that market, already equipped. So now they're pushing out this tech. Yeah. So a lot of the things that we've looked at, on meters and stuff, that's that the actual radio tech and things is sometimes 10 and 15 years old.
Yeah, and at the end of the day, right, the whole point of a lot of this stuff is that most of it's all just either an evolution of what was there before, or it's literally a bolt-on to what was there before. So at the end, right, you're talking SCADA protocols that are either over IP or over some sort of custom RF, but it's all still SCADA under the hood, and it's usually you start pulling these devices apart, and you can usually find where oh, that's actually a serial connection, like right there. That's a yeah. I know what that is. I can tap into that.
And as far as some of the other tech, obviously. Some of these things are actually on, currently on nailed WANs, and so these are actually like, a T1 that's going, from a substation or a plant, back to some central point where they do control of it. And of course, that's very expensive, right? A nailed T1 circuit's, say $1,000 a month or whatever. But that's what sort of existed, originally. And some of these things will be like dial-up lines. What we're seeing more of, lately is actually WiMAX technology. And it's not the same, it's not the same WiMAX that you see with, like, say, Clear. Typically it's on different frequencies, and this is not, obviously not ClearTech's not designed to be public. It has some of the same problems as other WiMAX technology. The Zigbee stuff, which you probably hear a fair bit about. Zigbee is essentially a reduced version of 802.11. And then also, like we mentioned earlier, some of these things are on cellular, so EVDO and CDMA. And actually, there are meter vendors out there that, and not just meter actually, but distribution automation vendors and things that support Wi-Fi. So straight up Wi-Fi, they'll do it. You can plug a wireless NIC and an AP and send this stuff over that. shouldn't be a problem at all. I think it's a fantastic idea. So,
yeah, and other terms that you'll see, HON and NON down here at the bottom. Specifically within the smart grid realm, that's talking about home area networks and neighborhood area networks. Home area networks are the smart grid stuff, like you can have a device in your house that'll tell you, that like talks to your meter or talks to some other device that'll tell you, you're using this many kilowatt hours and we expect your monthly bill to be blah. And then they can also get messages down from the utility, so they can tell you, hey, in the future when pricing is going to fluctuate more than it does right now, they can tell you like, hey, we're anticipating high demand on this day or whatever, so it's going to cost more, right? And the neighborhood area networks are the stuff that mesh all of that together. So those can be both the things that will link up like switching or substations and some of those other outside things, but primarily when it's talked about, it's the network that hooks up all the meters in a given area and then pipes that back up to some location.
Yeah, and obviously backhaul is just think the same thing as your ISP. You might have a bunch of neighborhoods that have say cable modems or whatever, and there's a CO or some point where all of those come together to a backhaul. So that the neighborhood area networks, there's some collection point that then runs all that stuff upstream via a little bit bigger pipe, and that's also where some of the actual management traffic and things is going to come out of. Some of that's out of band, some of that's actually in band. So you're going to see that. If you have access to see meter traffic or other traffic, you'll see the management stuff going across that as well. Like Nathan said, somewhere under the hood here, it typically is something that is really SCADA over IP. So it's at some point you're taking a SCADA protocol, you're turning it into IP. Some device, some endpoint is then taking that and turning it back into serial. So it's going to be RS-45 or RS-232 serial under the hood somewhere. Yeah, and just a map of the level of adoption and the stuff that we're seeing right now in our part of this part of the globe. There's the places where you're seeing a lot of the AMI, like we mentioned, are in particular a lot of the people that have got the stimulus funding, and that's pushing a lot of that. As I think a lot of people know, Pacific Gas and Electric and in California have been the biggest deployer of that. But there's lots of other big utilities that are moving this way.
So at the end of the day, what do we have? We've got network devices, right, that are talking this RF stuff that then you've given to every single person out there, right? That every person that has this particular technology in their area has these things bolted onto their house and onto random buildings around town and whatnot. So if in that type of scenario, you're dealing with a very hard problem to protect, right? You try to think about some of the people that have had to protect things in that type of space. Like I give you a device or I give you a piece of technology and you're not supposed to be able to pull it apart, and how hard that is and how well that works, right? Well, in this environment, I mean, if you wanted to go like steal one off the side of a house somewhere or off a building, and you have physical access to it and you have an extended period of time to work with this, you have access to the network. And it really needs to be viewed that way. That you've got to expect that at some point, individuals will be able to gain access to that network. It's just it's impossible to be able to adequately block that well. So there's lots of different ways that can be done, right? No matter if you've got hardcore encryption and all these other things going on. There are too many ways into that type of a system, right? So there's lots of other talks here and previous years talking about how to do that at the hardware level. We reference, Goodspeed, Davis, some of those guys. All great work.
Yeah, and we make the point a lot of times when we've talked to utilities about this that it's a lot like the problem that content providers have with DRM, or satellite companies with pay-per-view and things like that. So these devices have an expected lifetime of 10 and 15 years, right? And so even if they have like really awesome, super awesome crypto and all these other things, like they have the ability to interact with the network by definition. And even if you try to protect some of that, at the end of the day, the consumer has the means to join that network, and they have access to the device. Just like with the satellite stuff, if one person breaks the encryption and releases the information, right? So if everybody knows, I don't know, if nobody has a Dreambox here or does any of that stuff, right? That's not at all. It doesn't. I don't. If I participate in the sat hacking stuff, I don't have to be the guy who's got the latest codes that work. I just have to go to the forum where somebody else has posted. So it's the same kind of thing. Once one person in a given area has took apart the protocol or looked at it, as soon as other people get a hold of that information, potentially, those devices are out there for 10 and 15 years with other people having the means to do that.
Yeah, so kind of like what we've already said, that a lot of this, and you get to talk to people, and they'll say things like, well, but it's it's proprietary, nobody understands how it works, and it gives a very false sense of security, especially when you're talking to utilities who historically have not really worked in this type of space. They don't understand the types of threats that they're probably running up against. Probably, the people in this room who get something like that attached to their house, the first thing you want to do is pull that sucker off and figure out how it works, right? So it's a very different mindset and a new place for them. There's a real systemic lack of understanding and of really how competent and how aggressive some of these people are going to be, right?
Yeah, and on the other side of it, related to that too, it's utilities where they're used to this stuff now is sort of physical fraud. People that steal power. And so there's always the assumption, right, that that's what people want. Well, who's going to do all that trouble to get, to not pay $200 a month or something if you have, in the summer when your air conditioner is running, for electricity? Well, it's not really that. If you look back at, I think a lot of this stuff as being like the 1960s AT&T world, right? It's the guys, the phone freaks and everything that exploited those networks. They didn't care about getting free long distance, right? It was about exploring this network and figuring out what it does, And this stuff's really fascinating, and it does all kinds of nifty stuff. So people are going to take it apart. I think we're being stopped. Oh, sure. We'll go even faster after this. You good?
That's up. Yeah.
Just 1 year, guys. I'd like to not have to stand up here. We made it until 2 o'clock today, which is better than last year. How about next year we do it until Sunday? Several somebodies are eating a lot of food at Katie's and then not paying their bill. On the order of $100 plus type orders, where 7 people stand up and leave before paying the bill. Not once, not twice, several times. Very, very, very uncool. If you know who you are, no harm, no foul, go pay your bill. You were drunk, you didn't realize what you were doing, whatever. If you know who they are, step up, put some pressure on them, get them to go pay their bill. I don't know about you, but I happen to like this hotel, and this hotel so far likes us. The Alexis Park is a great hotel. I personally don't really want to go back there, because I don't like doing CPR on somebody in 110-degree weather. It's not a lot of fun. So please, stop being assholes, pay your bill, and if you walked out without paying your bill, go pay your bill. Thank you.
And if they don't come forward, walk over there and give somebody $10 at Katie's till it adds up to enough, guys.
Thank you.
Yeah. So yeah,
Yeah.
get back on.
All right.
Yeah. Well, okay. So, yeah. So same point. Actually, which is, Dine and Dash is not hacking, just like meter theft is not hacking. That's just being a dick, right?
Yeah, it's called theft.
Yeah, that's theft. It's called being a dick. Same thing. Just like the point I was just making is that, what the utilities are thinking is going to happen here is that, people want to steal power because that's what they're used to dealing with now. And, what we think is that it's not going to be about that. It's going to be about getting access to everything inside that network and mapping it out. Just like, guys like Joy Bubbles and in the 60s in the phone freak days, they knew AT&T's network better than AT&T did. It's going to be the same thing. And those individuals may not necessarily be trying to do any harm, but they might stumble across something that doesn't do what they expected. See also Mother's Day, whatever that was, 98 or 99, right? So, the vendors also are still very new to all the disclosure things. And
Yeah, you get into discussions with vendors on this, and they've never dealt with people like us before, right? And when they have, it's because usually they've actually brought them in themselves, so it's some sort of internal consulting engagement deal. It's very hard to talk to these people when you are not actually working for them. You try to get on the phone with somebody, try to, simple things like trying to ask questions or just clarify on things, and you get on the conference call and then you discover, oh, that's like legal counsel and some other VP, and the engineer that we were trying to talk to is nowhere to be found. And that's a very common thread through every interaction.
Yeah, and we would make a call and ask some little question to somebody in engineering, and they would give us an answer, and then the next time we'd call with another question, they'd say, I'm sorry, I can't. You're supposed to sign an NDA. We can't talk to you. And it's very much, that same kind of mentality that you saw, like the Snowsoft days and the Sue Happy kind of stuff that came out of the software industry when we first started really finding a lot of bugs and trying to get them fixed, right? So that makes it pretty tough to talk about this stuff. And one of the things that concerns us a lot is that actually, as near as we can tell, everybody that we've talked to that's done the stuff that we've been up to has found all the same stuff.
And none of us can talk to each other.
Right. At all.
We're all under NDAs with separate companies, and we all find the same bugs.
Yeah.
And you may hear rumors about things over a beer, but nobody's actually talking to each other in this industry.
Right.
So.
And we're fairly confident that actually utilities are all paying people like us and giving those vendors the same bugs, right? And so that's not a very efficient way to do this. So we talked a little bit about the serial stuff under the hood. One of the big things that that we find as far as simplest ways to interact with these networks, and something that we think is the most interesting about this, is that under the hood somewhere, whether it's soldered to the board, whether it's under whether it's literally a board that snaps in, somewhere you're typically talking RS-232 serial.
And you talk about smart grid meters, right? Where if you start looking at spec sheets for different meters that utilities can buy, you'll find that each one supports a whole range of types of networking options. So it's all the stuff we listed earlier on that other page. It's either custom RF, and then you also have like cellular things, GPRS and whatnot. And the way, of course, that they're doing that is it's all modular, right? I mean, it doesn't make sense to build like 15 different meters just because you want to talk to a different network. So somewhere in there is some sort of an interface that sometimes it's password protected, but it's an interface that's serial. It's not like I can't tap that and just watch that occur. So it makes these particular devices more interesting and perhaps easier to interact with than some of the other hardware RF stuff that people look at. And there's been a lot of work from say Goodspeed or Josh Wright with some of the Zigbee stuff, and some of these other guys that are looking at embedded devices and still seeing the same problems there, where separate chips that are not integrated, and so you can tap buses and do things like that. Well, it's even easier oftentimes in these cases because it's actually a fully documented serial protocol and you just got to find the right pins, or it's an actual like a snap-in. So.
Yeah. So what we've been able to do, in a couple different cases, is literally just essentially talk to the device that's the radio for, say, a meter, as if we're the meter, right? And use that as essentially a network card, to talk to. So then we don't have to worry about it encryption. We don't have to worry about any of the other things on the network. We're there. And they will actually refer to them when you start talking to the engineering guys. They'll call them modems, and that's because they really do. They act essentially like a modem. So, to that point, what we think is kind of the future of to speak to the theft of service side of things, is that rather than the way that people steal power now is that you pop a meter out and then jump the supply side across and put the meter back in, and then essentially no voltage goes to the meter. That's it. You've got free, or you take the buried cable in your backyard and jump that into your house, which we've heard stories about people doing. Is just dig till you hit it and then just tap that and then send that to your house. It's probably a good way to run grow lights, is what we hear. So instead of doing that now, right, what you're doing instead is what the utility sees with smart grid is the data itself, right? They're not walking to your house, they're not looking at your meter, they're not seeing if the dials are turning, they don't care about any of that, right? That's the whole point, is that they're going to pull this data remotely, and that's going to populate a database somewhere. So instead of messing with the actual power, you mess with the measurement of the power, right? So what we think is the most likely path that a lot of this stuff is going to go down is there are open source stacks in Linux for C1219 SCADA, which is the protocol that meters talk under the hood. basically you have that and a serial port. You take the card out of your meter and you plug it into your Linux box, and then you just send whatever data you want to send. You know, that's it. Yeah, and it's more complicated than that. It's not literally just plug and play like that simple, but it is pretty straightforward. I mean, if you look at the traffic coming from there, it's essentially just a number that increments, and that's your interval read. So you can send that number any way you want. You know, so that's, yeah, for us, it's the quickest way to get involved in the network.
Right, and so sort of along those lines, I mean, there may be controls around any number of these things. In practice, I think, and we talk about this a little bit later as well, but in practice, it seems that many of those controls are not actually turned on. So one of the things that we've been working through is trying to get, more like configuration hardening or things along those lines, where it's like, well, so this thing is probably sending events that say, like, somebody just unhooked me, right, and that's bad. And that's a sign that somebody's messing with their meter, and you might want to send someone out to the house to make sure that they haven't done something like what we just described. But maybe that message is not actually being replayed up to the utility, or if it is, maybe the utility is not actually monitoring it, right? So all of those things, of course, have to happen for you to detect that event occurred.
Yeah, and that C1219 protocol has an entire stack of messages that indicate different things that happen to the meter. This voltage changed, and this thing changed, or this power, this line was unplugged, or whatever. But all of those events create more traffic on the network, which means buying more relays for that network, which means creating more traffic. You've got to buy more gear and rescope, how many collection points you have versus how many devices, and so they're kind of off by default, in our experience.
Yeah, and one of the probably the most interesting things that we found when we looked at this was when we started actually digging into how utilities are managing those networks at like the ground floor. So you think about how things have been done for a long time. You've got all these techs that are used to being able to have full control of a meter, and they understand how it works, and they're able to go out and actually like repair meters and and whatever they need to do. They're used to having a high amount of control of this device. Now we're into this new world where we've got highly advanced things that are a lot of management's being sucked back up into systems that people are interfacing with through like web apps and stuff back at corporate. Well, all these guys, they really felt like they needed this ability to be able to interface with these meters and be able to go directly to a meter or go to a neighborhood and be able to talk to these guys. So we started looking at how that works and what that was like. And really what we found was that it appeared that that demand from customers was not necessarily anticipated. So what happened was that providers were taking internal tools that they were using themselves and then sort of retrofitting them and then giving them to a customer.
So you've got a field tech who's a guy who's been a meter technician for 30 years, and he's used to being able to go in the field and do all this stuff. And now you go tell him he's got to log into a website and run some commands in his laptop and do all that. He's like, no, that's not what we do. So you see from these different vendors a little box, a field tech box that does disconnects and reconnects and moves service around.
Yeah, and by definition, those guys need to be able to talk to like any device that they want to, right? Because they never know what kind of scenario they're going to be hitting. So these little devices are actually fairly dangerous little guys, right? And how they work is interesting because it's all the same problems that you see with hardware and OSs and everything from before with like default accounts and that kind of stuff, right? It parallels exactly where you've got these magical God keys that can talk to your entire network. Maybe they can talk to like other customers' networks that are just happen to be using the same technology. Maybe there's a magical bit you can flip and you can talk to all of them all at once. We also found the reason why we think that a lot of these tools were developed in-house and then later turned around and given to customers was that we started actually pulling the software apart, and you find all these extra commands and all these functions that are not hooked up to anything. Like there's this pretty GUI up front, and then all these DLLs in the background that have a whole wide range of functionality, but not a lot of it wasn't hooked up. So we just kind of said, well, let's hook this back up. Let's see what this does, and then you find all kinds of interesting commands that nobody is aware of, right? So.
Yeah, and our concern is that basically same thing, fastest path to that network. Just like interacting with the network card, the fastest path to that network then is to identify what one of those boxes look like and get it off of the dash of the utility guy that has a truck parked in his front yard, and he doesn't think that thing's a big deal. He doesn't know that it has signing keys and all kinds of other scary stuff on it. It's the box that turns meters on.
We parallel it a lot with some of the things that have happened in the GSM or cell phone world, so there's software from, and I forget who it was. I saw one of the edge hacking talks here
Quest.
a couple of years ago. I think Quest is the one that they make a piece of software that'll let you reprogram certain types of 3G cards, right? So you get the software, and it's totally illegal to have. I mean, it's like proprietary internal software that like only their techs are supposed to have.
It's class 1. Right. It's not class 2, I think.
Well, yeah, and it's not supposed to be out there, but of course it is, right? You can download it like on any torrent site out there and then reprogram this stuff and pretend that you're a tech, right? Well, so in this case you have hardware that also matches that, but it's kind of naive to think that software is not going to get out eventually, right? That when somebody figures out what you can do with this stuff, and that hey, this is actually kind of valuable, and that there's I just need to like steal a CD in a box off this guy's truck. I mean, it's entirely a different world. Again, and like I said, there were protections built into the software of, like functions that were hidden, and there was the user login stuff and all this. But I mean, it's trivial to reverse engineer. And I'm not an advanced RE, and I did it in about 15 minutes. And so I mean, it's the same problem of you've got people that are stepping into a very difficult world where they're trying to protect pieces of information when you have full control of it. Right, and it's like the Sony PlayStation problem or something like that. But these guys have been doing it for 5 years, not like 20.
So we talked about AMI for a while, and we're pretty much going to forget about AMI at this point. So I kind of have this thing of fuck meters. Meters are cute. They're cuddly. They're really super. Worms going around. Meters. Cats and dogs living together. It's bad stuff, right? But at the end of the day, that's not smart grid. That's the grid, right? Is the whole spiel, right? The whole shooting match. AMI is just the first wave, and one of the reasons for that is that it doesn't have a lot of footprint now, right? So that stuff's not wired up. There's a big consumer benefit. There's a lot of things that the consumers see out of it, and of course, obviously, it's a push to get real-time data, billing data, and be able to see that stuff in real time instead of a dude walking to your house once a month, right? But the longer term picture here is not about just the AMI side. It's about the actual backside here, distribution automation and energy management systems and all of that. And a lot of the motivation here, the green stuff and all of that has really come about in the last couple of years. The vendors in this space for years have been pushing this to utilities. Prior to that, they didn't call it green energy. What they talked about was that this gave you demand response in real time and data gathering in real time. The reason that you do that, if you remember a little company called Enron that kind of sold power short, right? They kind of sold it a little short, oops, and kind of took, say, a state offline for a while, oops. A lot of that comes down to the fact that their data gathering and what they had was at monthly increments. That's how they're predicting this.
And a lot of you guys probably run networks, right? So imagine if you were trying to deal with what your bandwidth demand would be, but you had like no idea how much bandwidth was being used, right? Like you
Let's
had
say you're
some
Comcast.
very rough signposts, like once a month or something, you found out that, we use this much. So you would buy a whole lot extra, and you just hope that you didn't run out. Right? So that's kind of where it is right now. But this stuff is going to give you highly detailed information, maybe every 15 minutes, maybe every hour, but you're going to be able to have very highly specific info on how much energy is being used in a given part of your area.
Yeah, and so right now, basically the way it works is you essentially overbuy on capacity or you're hosed. I mean, that's pretty much
Yeah,
if you don't
overbuy,
if you don't overbuy, bad stuff happens, right? So when you can see those curves and you can predict it a lot more, what then happens is that, and yes, at the end of the day, that means that we're going to use less, electricity because we're going to have better data. But it also means that the utilities trading markets become more like NASDAQ, more like real time, and so that stuff can move around a lot faster. That means profit for everybody, right? So that's really where a lot of this stuff came from, and then the green stuff kind of came after the fact. So yeah, at the end of the day, what that means in order for that to work is that somewhere power on the grid, decisions about what's going to happen to it are being made in software.
Right, and then all that's being implemented over RF down to lots of little devices all over a city or a given state, and these little switches that flip on and off and move power around, right? And what we found is that all of that, or the majority of that, is happening over RF in our experience.
And meters are freaking cute. Right. So, that was kind of our conclusion. We looked at a bunch of meter stuff for somebody, and we're looking at some of that. And well, can you look at we have these other things we probably should talk to you about, And so what did they do? And oh, you know, substations, you know, plant control, nothing, you know, nothing really important. And the deal with that, and that's, yeah, actually I think we have some of this on this next slide. The deal with that is that that's stuff you don't fuck with. Okay, so you can take neighborhoods to offline. Dude knocked on your door if you've got, you know, new meters lately, and it happened to me. I said, no, come back. I'm working on a dock. You can't take my network off, you know. But it came by and said, hey, I'm just gonna take your power off. I'm doing something, you know, or whatever, for 5 minutes, and he pulled a meter and popped it back in, right? And then poof, you're on new tech, all new stuff. You can't do that with a recloser. You can't do that with a substation. Okay, so what happens is you take the existing stuff that's out there, which is modem lines, serial. Some of it is things that you have to physically walk up to, and you bolt something onto it. And yeah, these things are typically, they're already networked in some way, and now it's about, let's get all that stuff up, just like the meters, and let's get it up in real time and have a real network. So, yeah, and in a lot of cases, that's going to be via something like WiMAX, it's going to be cellular. And in a lot of cases, the vendors that sell the meters are selling the back-end tech too, and that's a selling point. It interoperates with your meter tech. It's all the same gear.
Yeah, so you've already spent this money on infrastructure to have this, you know, blanket network, this fancy mesh stuff everywhere. And now, oh well, so this is the same thing, right? So I can take advantage of that, and I just plug on an extra NIC to that, and I'm done. Right?
Yeah, and in some cases, we've seen that actually mean that there are literally Ethernet drops in boxes and on poles. So you have a device that was previously on a nailed circuit over, you know, something that mapped out to, you know, there's a router hanging off, there's something that mapped out to, you know, came Ethernet off of there, and that's just getting plugged into some wireless device. And literally up on a pole or with one of those same cute little locks that you have on your meter outside.
Yeah, all these devices that you would use to retrofit old tech like that, they're basically RF with either a serial interface or like a Cat5 cable, right? And so you'll start looking around, you'll see see the little, oh, that's a Cat5 cable on that, like right there. That, I wonder what happens if I were to tap into that, right? Mm-hmm. And you talk to people about, oh, so what are the kind of security around these things? And you know, it's this type of deal, and yeah, there's a fence, and yeah, there's maybe a camera, and and they tell you things like, well, yeah, I mean, it's in a secure location, but we've got this huge problem. People keep breaking in and stealing all our copper, right? And so you're like, well, okay, so I recognize that there is a fence, but I also recognize that apparently you have a problem with people regularly breaking into this environment, and you can't really stop them. So. Right, what does that mean with this stuff, right? Where it literally is a network cable, and hey, I could put like a vampire tap on that, or I could just unplug it and plug myself in. Mm. Where does that drop you? What does that give you? In some cases, it drops you on a subnet with a whole bunch of these other devices, right?
Which all talk again, skate over IP via known protocols that in some cases may or may not have any other controls around the communication. And actually, larger point, if you work for a utility, like really simple, guys. IPsec is your friend. We use it on the internet. We like it. We've used it for a long time. Seems to work pretty good. So put that on that stuff. And there are vendors that do that. If you're going to take your Ethernet drop through your SCADA and everything and hang that over some long-range FHSS radio or WiMAX, whatever the hell it is, put IPsec on it first. And if I break that protocol on the wireless end, I'm still just going to see IPsec traffic.
Right. Or if I get on that network, all I'm going to see is an IPsec endpoint. And yeah, so you've got this. Those are all over the internet, and we feel relatively confident about those.
Yeah. They're not fantastic. I mean, don't get me wrong. I'm not going to defend IPsec, but it's better than what we're seeing. And just another example. That's a recloser. So these devices, and they usually have, like, say, actually modems or GPRS or something hanging off them now. These are essentially circuit breakers. So when your load changes, you have an outage that say lightning strike or something else. This is going to essentially just flip a really big stinking breaker, okay? And it's going to move power over one direction or the other. No, just 10 minutes. Yeah.
So we've spent a lot of time talking about, so how all this stuff works, how it's put together. We've talked about some of the hardware ways to tap into these networks, right? Literally unplugging stuff, hooking in, tapping on specific places on like a board or something like that. But we'll probably, we've got 10 minutes left, so we'll go ahead and switch over and just start talking about
some of the things that we use to connect to this stuff. Yeah. So Zigbee, we're not going to go into a ton of detail about it. Josh Wright is awesome. We love Josh. We'll buy him beer. The Zigbee stack historically, in order to interact with Zigbee, you had to buy essentially these developer testbed kits that Digi makes. They're called XB, and they're relatively expensive, a couple $100. With Killer Bee, you can buy Atmel cards that are about $40. You need a JTAG that you can write a custom firmware to it, but it's pretty straightforward to do. Basically, what that gives you the ability to do then is the same kind of thing you do with wireless, where you can do injection, you can sniff, you can go into, you can monitor traffic and things, and so this gives you the ability to interact with Zigbee gear a fair bit. So it's neat stuff.
With specific application to smart grid, it does not support the SEP stack. So there's a I don't know how much you know about Zigbee, just real quick. It has these different profiles that kind of block into it, and it hooks down lower, and it sets certain configuration parameters, stuff like that. There's those set for smart energy. So his stack does not actually talk smart energy, so you are somewhat limited in what you can do with his stack. You can also go out and buy like a stack from it was XB or some of those guys for like $200 or $300, and then you have a full SDK that will allow you to build applications that will interact with that network. So.
Yeah, and actually there's so like we said, Zigbee's kind of reduced 802.11. We're all used to like layer 7 model. So Zigbee is kind of, you've got a real basic network layer that's like a much simpler network stack than what you would see in, say, something that's full 802.11 or like wired Ethernet or something. The larger point about Zigbee is we talk about Zigbee itself a lot as being sort of intrinsically bad. It's not fantastic, don't get me wrong. But SEP, the smart energy profile that the utilities use, does add a lot of extra security bits on top of it.
There's been problems with Zigbee in the past with, say, like over-the-air key retrieval and stuff, where when they first hook up, it'll actually transmit its encryption key, clear text. Well, as an example, SEP says, no, you can't do that. Like, you are not allowed to do that in this environment. Yeah. And so that key management stuff all has to happen outside, in an out-of-band process. So that's one example of ways that it actually locks down the sort of default Zigbee protocol.
Yeah.
And so, overall point with Zigbee is just that we actually kind of like it. As far as comparing it to what your other options are, it's been looked at by a lot of really smart people, and it's
by no means fantastic, but if we're grading on a curve compared to the other stuff we see, it's not so bad. So, something else, and we talked a lot about this. Something that, and I know that there's somebody else that's doing some talk about some of these things. The FHSS, frequency hopping spread spectrum, is what those substations and reclosers and things. What we see a lot of that stuff running on. This is a technology from World War II. It was based on the concept that back then radios were difficult to tune. You had to solder a new crystal on, essentially to get wider bands and stuff. So it's meant for some other. There's some other good reasons and things like interference with radar and all this other stuff that you want to hop channels, and it does give you longer range and a lot of other good stuff. But the security argument for it is that you have to be able to follow the hops on an FHSS radio.
And it's funny, if you go actually to the Wikipedia entry for FHSS, you'll see a bullet point that says FHSS provides security. Like that, it's a selling point of FHSS, and that it's hard for you to do narrowband interception and like listen and know what channel it's going to be on.
All of you go edit that entry when you get back to your rooms.
Exactly. But so how do you fix that, right? Well, just do wideband interception, right? Listen on a band that's wide enough that you can see every single channel, and then it's irrelevant where it's hopping, right? And you can watch that long enough, and you can figure out the pattern. And most of these guys, their algorithms will repeat themselves. So then you can just learn what the pattern is, and then you know what that pattern is always for that device that's talking to this other device.
Yeah.
Right?
And the wideband interception capability didn't really come about till pretty recently for that to be easily accessible to people. That's where the USRP. Anybody went to Chris Padgett's talk knows all about that stuff. The USRP2 gives you a much wider band that you can sample off of. So, previous stuff that people have done against FHSS with that device, with the older version of the device, had to like watch one side and then the other side. With the USRP2, you can pull enough that we can just see all the samples.
We're pretty much out of time. Do we want to?
Yeah, we won't say a whole lot about the USRP. Or GNU Radio, which is the API to write to that.
Just
go check it out.
I would say about GNU Radio, it's got a fantastic API that'll let you do a whole bunch of stuff.
A fantastic yet horribly documented API.
Yeah, and don't ask any questions on IRC or on the mailing list, or you'll just get slapped.
Yeah, they'll just beat you if you don't have a PhD in EE.
Right. Did you not go read the docs, like the the big like double E book, right?
Yeah. Well, they'll always send you to there's this, and we have the book now, but there's like this 600-page book on signals design and stuff. That's like, I guess apparently grad level courses in double E. That's what you read, and so any question you ask in new radio, they just like point you to that book and say like go buy that, and then come back and ask. But yeah, it's really neat stuff. Like we talked about, what we found with things like FHSS is that by doing sampling and a wide range capture, we would be able to see those ranges. Something else that we found, and we'll actually talk about this again in a minute, is looking up things like FCC documentation. A lot of times those docs will have all the detail about how these radios work. They'll talk about the hop sequence. In a lot of cases, they'll even put the documentation there. Also see that in patents. You'll see it in IC searches. We also found that like finding all the resumes for all the engineering teams for a company would tell us a lot about, like if you look at their background, it's like, okay, he's got a lot of background in OFDM design. And this guy did, his PhD thesis about, 4G FSK. We probably know what kind of modulation he did when that company hired him, right? So that helps us a lot in looking at this stuff. Just a random example. This is a Digi radio. It's a serial radio that is in use in a number of places for essentially giving you the ability to take a serial port, send it over wireless, really dumb, stupid radio. And if you pull the FCC ID on that, it will tell you all the hop sequences, the channel spacing, the device does lots of other stuff about it. It tells you the modulation, the channels, the dwell time, and actually the modulation type that they use. The other thing that...
Right, so what we're showing here, after you pop out the shielding, you can start tracing and looking up what the different chips are doing. Right, so this particular chip is the chip that handles basically radio for this guy. We looked at some others that had actually highly detailed data sheets that were available that'll tell you explicitly what its options are. Like it supports this modulation in this one and these like 5 options for those. So it drastically limits down the number of things you've kind of got to brute force through to do this. And I probably, like real EEs probably look at this stuff like as, they'd like put their finger up and they're like, oh, that's GFSK, right? Well, we can't really do that, so we cheat, right? And so like look up the documentation. It makes it really easy.
Yeah, the guy that, somebody told me, the guy that's done all the Bluetooth work with breaking Bluetooth, that he can actually listen to Bluetooth over audio and like hear it and go, oh, I know what that is. Yeah,
they're transferring an image.
We're not nearly that smart. So for us though, these data sheets, the IC data sheets, they're meant for people that buy this chip. And they'll tell you, essentially the reference spec for this chip for how to write, these voltages do these things on it. So that narrows down the number of things that we need to figure out on our own very quickly. And we found that to be extremely helpful. Here's just an example of actually taking a wideband sample that was over a large range frequency hopping.
Yeah. So the green line at the top is that's the highest point that it's seen on that channel, right? So each one of those spikes is a different channel within that range, and it's hopping between them. The blue line is what actually is currently being looked at, and so the top line is that it's showing the entire range and what's occurring. The bottom line, or the bottom section, is showing we're looking at this individual channel right here, and then we're doing demodulation based on all the stuff that we looked up from data sheets, and we're able to get that out. And then all those things actually correspond to ones and zeros in one way or another. There'll be decoding and encoding that might need to take place after this, but basically, that's ones and zeros that you're watching right there. Just as if, and some of you hardware guys recognize things like that from logic analyzers and things that are happening at that level. It's same stuff, just over radio with different types of modulation.
Yeah, and that's just an example of an individual channel and what in this case FSK might look like. But yeah, the differences in those waves, that's how you get to zeros and ones. So if it's just clear text and that's there's nothing else in play, the mojo here is just getting to the point of figuring out how they got to zeros and ones and building that in software on your end to get to it. Same process that people have done with Bluetooth and GSM. The suck part about proprietary protocols is you have to do this every time. You've got to go through that process with each radio.
So every time you look at a new radio, you got to go through the same process. And we've gotten better at it in that what we've done in 2 weeks, what took us 6 months before. But but it's still a big process.
Yeah, and there's lots of other things. You've got to identify the encoding, the symbol rate, the endiness. Like I say, a lot of that will come out of the biggest thing we find is using the ICs and the FCC data and stuff like that helps us a lot to get the right direction. Yeah, and basically at that point, you just spend a lot of time brute forcing the signal till something comes out that looks accurate. And we're way out of time. We had an hour 15 at Black Hat, so I'm terribly sorry. Yeah, the only other thing, actually one thing I will say, is the other thing that we find is when we get under the hood on a lot of these radios, they have something like an SSID for a wireless device, like same kind of thing. There's some kind of network ID. What we've found in a lot of cases is there might also be some undocumented things that will do things like a promiscuous mode, same thing as a wireless device. And also maybe a channel that will allow you to interact with all other channels. And this would be, that would apply to meters or these other kind of radios. So when you get physically a hold of one, sometimes you don't even have to break the protocol. If you use that card and maybe look for some things that aren't on by default, it'll help you out a lot.
So we're going to go, what room are we going to be in after this?
Capri 112.
Capri 112. So you have questions, come see us there. But we got to get off the stage. So
yeah.
thanks, guys.
That's right. Thanks.